All right, so now that we've established some logical operations, let's talk about this idea of compound propositions. A compound proposition is essentially a new proposition that you build by combining other propositions together. So here's just an example, just some complicated example I just made up. So here's P and not Q implies not P or R. This entire thing, we could say this is going to be A. We could give it a new name. We could say this whole thing is now a proposition, and we're going to call it the proposition A. So, I want to make very clear this idea that when you combine things together using operations, the result is still a proposition. Okay, and it follows all the same rules as propositions. This is just like when you take 2 plus x. 2 and x are both real numbers in algebra class, and when you add them together, the result is still a real number, right? And you could give it a name. You could call 2 plus x, you could say, let's call that A, and then work with that. That's what we're doing here. Now, in order for us to understand how exactly to interpret these compound propositions, we need some kind of order of operations. So, for example, how should I interpret this statement here? Should I interpret it as like P and not Q? That whole proposition implies this entire proposition of not P or R. Should it be that? Or should it be like P and then maybe the implication takes precedence and we say not Q implies not P, and then that, how is that combined with the or R? Is it that whole thing or R? I mean, there's lots of different ways we could kind of group these things together. We could say P and not Q. All of that implies not P, and then we take the truth value of that thing and say or R. All of these different ways of arranging parentheses are going to give us like different meanings. So when I write P and not Q implies not P or R, when you write this, we need to have some common understanding of where the parentheses are implied. Like which operations take precedent over which other operations. So that's called, I've just said it, it's called precedence or precedence of logical operations. It's also essentially just the order of operations, right? Just like how in algebra we know that multiplication is applied before addition, and so that you don't need to use parentheses because we all agree that that's how it's going to work. So the order of logical operations is like this. First, negation. Negation applies before anything else. Then and. And applies before or. Okay? Then we would apply implication, and lastly, biconditional, double implication. But, as always, parentheses override. Parentheses override. Just like in algebra, we use parentheses to override the order of operations and say what order we should evaluate things in. So let's look at some examples. First example, let's say you have not true and false. So this is essentially a compound proposition using T and F to represent like constant truth values, right? So far we've been looking at combining things like P and Q, which are variables, right? But here we have T and F. T and F are constants. This, we can evaluate this directly, okay? We should apply the negation first, before the and, okay? That's what the logical order of operations is telling me. So first I negate this true and get false. So now I have the not true is a false, and then so now we have false and false, and then I can evaluate that. False and false is false. So that's the overall value of that expression. This is like you can think of it as like an algebraic expression. You're just evaluating it or simplifying it. Okay, and I'm using a triple equals here. This is not a double. This is not a regular equals. This is a triple equals. That in logic means equivalent, and we're going to define that soon enough. Okay. We're going to define it in the next video, actually. So, sorry I'm using something before defining it. I shouldn't do that, but it's hard to get around. Let's take this exact same expression, except let's introduce some parentheses somewhere else. Let's put parentheses around the true and false, like that. So you're going to see how introducing the parentheses to override the order is going to change the result. So now we evaluate what's in parentheses first. True and false is false because they're not both true. So we have the negation of false, and now that is true. So as you can see, the value changed. We're going to do that again. Let's look at one more example, or two more examples, where we look at one thing and then we look at the result, or another version of it with parentheses in a different place. So for this one, let's look at false and true implies false. So the and is going to take precedence over the implications. So that means that we'll evaluate the and first, and then we'll evaluate the implications. So first we'll do false and true. So false and true is false. So now this can be simplified to false implies false, and false implies false. This part is false. The first part here is false, so that means that it's going to be vacuously true. So this whole thing is true. That's vacuous truth. By the way, I'm writing vacuous not because it is some sort of special qualifier on the truth of that statement. No, it's actually true. Okay, I don't need to qualify it. I'm just writing vacuous as a reminder that the reason this is true is because of that vacuous truth. All right, so now let's look at the same statement, but let's put parentheses in there. If you put parentheses around the implication, like that, okay, true implies false. So now let's evaluate it. We'll evaluate the implication first. If it's true implies false, that's going to be false. That's the one situation where an implication is false. So now this is false and false, and now combining those, we get false. So we see, so these examples demonstrate how order of operations is used and how overriding that order of operations with parentheses can change the result.